students, good morning. Today we'll continue the macromolecules. Okay. See, in the previous class you are well familiar with the preparation of polyethylene, PVC, polystyrene and also PAMA. Is it? So now today we'll move on to the mechanism of addition polymerization reaction. Okay. So the four examples what you have studied in previous class, they are prepared, or the mechanism involved in that polymerization is addition polymerization. Today we'll learn what is addition polymerization and how it takes place. So the mechanism behind the addition polymerization. Okay. So this mechanism includes three types of mechanism. So the one is free radical polymerization reaction, ionic polymerization reaction. Once again, there are two types, cationic and anionic. And the third one is coordination polymerization. So under mechanism of addition polymerization, there are three types. First one is free radical addition polymerization. Second one, ionic addition polymerization. Under that, cationic addition polymerization, anionic polymerization, and the third one is coordination addition polymerization. Okay, so today we'll discuss the first one, that is free radical polymerization. So what do you mean by free radicals? Free radicals are nothing but they are the odd electron spaces. They are odd electron spaces and which has no charge. They do not carry charge. And now say for example A2 is a molecule. When it undergoes homolytic cleavage, when this bond breaks homolytically, so the two covalent bond means which is made up of two electrons, and each electron is taken up by each bonded atom. So thereby there is, on breaking this bond, two active species are formed. Such species which has no charge and which are odd electron species, they are said to be free radicals. They are very active species. Okay. So now usually, suppose say such free radicals are the one which are helping in, so carrying the polymerization reaction or addition of monomers with one another. Okay. So now this free radical polymerization reaction, which includes or which involves three steps or three stages. The first one is initiation stage, second one is propagation step, and the third one is termination step. Okay. So in the initiation step, usually such free radicals are formed. See, in the initiation step, suppose initiator is the I. Okay. When it undergoes thermal decomposition or say homolytic cleavage, it produces free radical. For example, benzoyl peroxide is one of the very good initiator or free radical generator. Okay, the benzoyl peroxide formula is say C6H5 COOO COC6H5. When it is subjected to say thermal decomposition, this bond, the bond between these two oxygen, which breaks homolytically, and thereby it gives two free radicals. Actually it's a benzoate ion, but it is not ion, it is a free radical. It doesn't carry any positive or negative charge, hence it is said to be a free radical. And suppose say this free radical is denoted by R dot. Okay, R raised to dot. Suppose say that R dot or the free radical R, when it reacts with the monomer. See the monomer in general I have given, say CH2 double bond CHX. Suppose X is H, it is polyethylene. If it is ethylene, if it is X equal to H, it is ethylene molecule. X is equal to Cl, then it is a vinyl chloride. And if X is equal to C6H5O, then it is styrene. Is it? So now, say in general it has taken as X, And when this monomer is reacts with the free radical, say this bond, double bond, the free radical attacks the molecule at unsaturated site. That means this double bond, one of the bond will break. This attack the bond, and that thereby the bond will break. See, the electron is taken up by this R, and the another one will goes to here, and the site of free radical is shifted to on this carbon atom. So now on reacting, it gives RCH2 CHX dot. So this is said to be a say new free radical. Say this is the initiator. From the initiator, when it combines with one of the, so one monomer, it gives a once again a free radical. So this is also a very active species, and it is eager to react with many more number of say monomers, and therefore this is said to be a growing chain, and it's an active radical. Okay, so now this is about the initiation step. Under free radical mechanism, there are three stages: initiation, propagation, and termination. Under initiation, so first there is a formation of say free radical from the proper say initiators. Okay, and thereby that will react with the say monomer, gives once again a free radical. Okay, now the second step is chain propagation. The first step, so whatever the free radical is formed, the new one, that means the initiator, when it is combines with one of the say monomer, so it gives once again a active species, that is free radical, and this free radical is in the second step going to combine with large number of monomers, and giving a thereby giving a polymer free radical. Once again this free radical site is goes on shifting say n times, and later at the end it will be on the last carbon atom. So this is once again a free radical, but it is a macromolecule, it is a macro free radical, and now still it is very active, and therefore it is said to be a living polymer. It is said to be a living polymer, and this will be ready to react with still many more number of say monomers. Okay, therefore it is said to be a growing chain, or a growing polymer, or a living polymer. So this is the propagation step, where the desired number of say monomers are added, and in still till to the end. So the resulting molecule, macromolecule, is also a active free radical. Okay, now with this we'll move on to the third stage, that is termination. Okay, in the first stage you have initiated, in the second stage you have propagated. That means the lengthening of chain is conducted, or it's done, and in the third stage how to stop the reaction, isn't it? So that is said to be a termination step. So in the termination step, once again there are two methods. One is coupling of chains, and the second one is disproportionation. So coupling of chain means such two chains are taken and they are subjected to coupling. Okay, so they are made to react with one another. So what happens here, say this is one chain. Suppose I have taken two chains, and here I have noted it as N1, and here it is N2. The numbers are different, and these are the say free radical sites. Okay, so now this chain, when it combines with this one, say these two will going to electrons are going to participate in the formation of this covalent bond. Thereby the two chains are combined. Okay, now it is a big macromolecule, or it is a polymer, and now it can be said as dead polymer. This polymer is no more active like these species. There it is no more active like this species. Therefore, it is said to be a dead polymer, or it is a macromolecule, or say it's a polymer. Okay. So now the second method, disproportionation. Once again, the same two types of say molecules or the macromolecules are made to react, then this hydrogen atom of this from this carbon atom, say the second carbon atom, this hydrogen is going to shift to the another molecule. So thereby what happens here, there is a shifting of hydrogen and thereby there is a unsaturation, okay, and this leads to the formation of a, say, two molecule. There here by shifting of hydrogen atom, this molecule is becoming a macromolecule with unsaturated property. That means, say here in this case, after shifting, so after the reaction with the first molecule, N1 molecule, here it appears double bond, okay, by shifting this one, and this molecule, the second molecule, say by accepting that hydrogen, it becomes a saturated polymer. So there are two polymeric molecules are resulted. One is unsaturated polymer, another one is saturated polymer, okay. So this is about the, say, the preparation or the mechanism of addition polymer. So once again, say the mechanism of addition polymerization. There are three types of mechanisms. So one is according to, say, free radical polymerization reaction. Second one is ionic polymerization reaction under cationic and under that cationic and anionic. The third one is coordination polymerization. Okay. So in each step, say the mode of, say, formation of different species are different. Okay, now we'll discuss only under the free radical polymerization reaction. Okay, so we'll leave these two. Okay, we'll continue in the, so we'll discuss in the next class. So today we'll discuss only the, say free radical polymerization reaction. In the free radicals, so free radicals are nothing but they are the odd electron species which has no charge and which are formed by homolytic cleavage of a covalent bond between the two atoms or two molecules. Thereby, say, it results in the formation of free radical. And in the initiation step, there is a formation of free radical. For example, if you take the benzoyl peroxide, so which gives two, say, free radicals is this benzoate ions itself, benzoate free radicals, and that free radical, suppose this is represented by R, and R when it combines with the monomer, okay, it gives a new free radical, and this is very active species. It is going to combine with many more number of, say, monomers, thereby it gives a polymer. And once again it is a free radical. The free radical site will be shifting, and this is said to be a growing polymer or it is a living polymer. Because it is living polymer means it is hungry, that means it is still ready to accept, say, many more number of monomers. Therefore, in the propagation, the chain will be goes on lengthening as the number of, say, added monomer increases. Okay, and the resulting polymer is once again a free radical. It is an active species and ready to react further. Okay, so the third step, there is the chain termination step, where the lengthening or growing chain is stopped. How to stop? How to, say, get the neutral molecule? So in the termination step, there are two methods. One is by coupling method and the second one is disproportionation. Okay, in the first, coupling means when the two free radical polymolecules or the, say, chains are combined, say these two sites are going to combine, results in the formation of a covalent bond between the two chains, and now this is the neutral, or that means it is a stable polymer or a macromolecule. Now we can call it as a dead polymer. Now it is no more active to react. Okay, so now in the propagation, the question is how long it takes, how long it takes place. It takes place till all the monomers are consumed or exhausted, is it? All the monomers are used up in addition polymerization reaction. So after that, after getting such macromolecules in the radical form, when they are under first step, when first method, according to first method, when these two chains are coupled each other, gives a macromolecule. And the another method is disproportionation. Say there is a shifting of hydrogen from one molecule to the another molecule. Thereby, the first one which loses the hydrogen becomes unsaturated molecule like this, and the second molecule which accepts that hydrogen, it becomes a saturated polymer. Okay, so like this, the chain polymer, that means the length in our chains can be terminated, or the chain reaction can be stopped or converted into a polymers, that means into a stage where the further reaction is stopped, and thereby getting the desired macromolecules. Okay, so with this we'll continue in the next class. Thank you.